Following on from last lesson, we're now going to be looking at braking distance and stopping distance. Our learning objectives are to explain the factors that affect the distance required for road transport vehicles to come to a rest in an emergency situation, and to estimate how the distance required for a road vehicle to stop in an emergency varies with speed. We're going to start by looking at the different parts of an emergency stop. To begin with, the driver needs to recognise there is a need to stop. He then needs to process that information and recognise what action he needs to take. After that, he or she needs to move his foot to the brake pedal and finally apply the brake until the vehicle comes to a stop. Here we have the situation where a cat is in the middle of the road. The motorcyclist then sees the cat and recognises the danger. It then takes him time to respond by applying the brake. And then finally the vehicle comes to a halt. The thinking distance is the distance the bike travels from recognising the danger to applying the brake. The braking distance is the distance the bike travels between the brakes being applied and the bike coming to a complete stop. The stopping distance is the total distance the bike travels between recognising the hazard and coming to a stop, and it is the total thinking distance plus the total braking distance. We can calculate thinking distance using speed times reaction time. Braking distance can be calculated by taking the initial speed or velocity and squaring it, and then dividing it by twice the acceleration. This is just a rearrangement of the equation v squared minus u squared equals 2as, for those of you who might remember that. Here you can see thinking distance and braking distance together. If you look at the thinking distance, it is proportional to the speed, whereas the braking distance is proportional to the speed or velocity squared. I'd now like to pause the video and, using the information presented on this slide, plot a graph of thinking distance and braking distance against speed. Now, using the graph that you've just plotted, try and answer these three questions. Pause the video while you find an answer. For those of you who like to stretch yourself, you can try answering these two questions as well. I'd like you to try and work out if the mass of the vehicle is likely to affect the thinking distance, the braking distance, or both. According to F equals ma, the brakes will have to apply a larger force for a vehicle with a larger mass. Therefore, the braking distance will be larger. Will driver's reaction time affect thinking distance, braking distance, or both? Driver's reaction time can be affected by a number of things. Longer reaction times will cause a greater thinking distance. Remember that faster reactions will mean a shorter reaction time. Will the speed of the vehicle affect the thinking distance, the braking distance, or both? At a faster speed, the vehicle will travel further in the same thinking time, but it will also take longer to stop once the brakes are applied. Speed affects both thinking and braking distance. The amount of friction between the tyre and the road surface affect the thinking distance or the braking distance. Decreased friction between the road and the tyres will create a greater braking distance. As one final point, just remember that for the car to be moving forwards, its tyres have to push backwards on the road, just like you have to push backwards on the ground to step forwards. This is Newton's third law. For every action, there is an equal and opposite reaction. That brings us to the end of the lesson. I hope you found it useful.